All right. Hello and welcome to everybody that is getting joined in. We went ahead and started a couple seconds early just to give everybody an opportunity to join in on the call and receive the information that we're going to be giving out today. And so that information being evaporative emission systems and some of the things that are going to be helpful to you, not only to know within the category, but helpful to you whenever it comes to conversations with technicians, shop owners, DIY customers, and even your peers at the stores around some of these components, so that everyone can have a better understanding of really what they're meant for, what they do, and what the overall category looks like when it comes to dollars that we can put into the register. And I'll tell you, I think it's a lot, and you're going to see that here in just a second. We've got a slide coming up that's going to give you a piece of information that a lot of people probably didn't think would be true, but in 2024, some things changed. So with that, before we get started, don't forget we have upcoming calls for the rest of the year here. Today is evaporative emissions, but next month we'll be talking about advanced ice technologies, then ignition coils, and so on and so forth. So don't forget to take a picture of the QR code there. That way you can either access it later or you can access it right now. We also have the link there that you can drop in the URL. That'll take you to the registration page so you can get registered for the upcoming calls towards the end of the year here. So I alluded to there's something being different in 2024, and that's one of the reasons we're having such a high level discussion of evaporative emissions control, and that is the fifth most common check engine related repair in 2024 was replace evaporative emissions purge control valve. That's pretty wild, right? We think about ignition coils being a check engine light problem, fuel injectors, a sensor, something like that. That would be some of the most, you know, priority things that have people coming into the shops. But it turns out the fifth overall thing was around the purge control valve. But here's what we need to understand. When it comes to evaporative emissions, this is really the first point of contact or reference that most people are familiar with. And what I mean by that is motorists aren't going into the shop and saying, hey, my car smells funny, or it makes a funny sound, or it's not running right. It's typically just the concern that the check engine light has come on. Now, in the old days, there might, have been maybe a couple different things that could have caused a drivability concern, but for the most part, this is now a no symptom emissions related failure that turns on that check engine light and brings the customer to the shop. They're not experiencing anything, they just know the light's on. Or in some cases, and I've lived in many of these areas, where you have to go and have your emissions testing done every year. Well, they're not going to pass that emissions test if that check engine light is on. So they may be coming in just to say, hey, will you turn this light off? I got to go get my emissions done. Well, they're going to do a diagnostic and find out, well, I can't just turn it off. We've got an EVAP component that's failed. And this is where customers are finding out. And so our goal really here is just to understand at a kind of a high level what emission systems and evaporative emission systems specifically do. Why do we have them? What's the benefit of them, and how do they operate? And we have to understand going into this that these are there for a reason, and they're there because the EPA and CARB mandate it. Now, here's the difference though. The EPA and CARB, they do not tell the OE manufacturers how to do it. They don't tell them you have to put this or that on the car, or these things, or this system. They really kind of leave it up to the manufacturer and say, you know what, at the end of the day, we don't care how you accomplish this goal, but the goal is to not allow hydrocarbons to leak into the atmosphere. That's all they care about. As long as that doesn't happen, they don't care what system they use. So manufacturers are going to use different strategies and different components to achieve that end goal, making sure the hydrocarbons are not being released into the atmosphere. And so this is one of the reasons now we have the fifth most common being purge control valve, because in order to make sure that we don't release those hydrocarbons, we have to purge them. And you'll see how that works here in just a moment. So again, how does it work? What are the most common types of leak detection systems? Again, this is high level. We're going to go over just a quick review of it. We're going to talk about how some of the systems, fail, what the components usually fail because of, a couple of tech tips, and then we'll go over some engineering improvements for durability, competitive landscape, and the sales support you have backing you up when you have these conversations. So, how does it work? Well, here's the thing. Let's consider this as you're putting gas in the car. You're at the gas pump. As you're displacing that air that's already in the tank, it has to go somewhere, along with the vapors that are coming from the fuel that you're putting in. And so those, the vapors have to go somewhere, And what lawmakers told manufacturers are you have to capture those vapors. So they have to go somewhere, but they have to be captured. Again, we don't care how you do it or what method you use, just as long as you capture it. And you have to be able to test to make sure that A, you did capture it, and then B, that you can purge it and you can draw those fumes out of whatever storage area you captured it with. And we also have to verify that there are no leaks into the atmosphere from any other portion of the system. And then we have to monitor the components to make sure the circuit is working and there are no out of range values. When we have those out of range values, we're going to get a check engine light. When the PCM cannot detect purge, we're going to have a check engine light. So there's a multitude of things that can happen with the evaporative emission system that turn that light on. And that's what the EPA and CARB want. They want that light to come on when there's anything wrong within this system or it's not working properly. But as you can see in the graphic here, the way this works, again, we have our fuel tank pressure sensor. As we're putting the fuel in, those vapors are going to be sent over to the vapor canister or the charcoal canister. There's multitudes of ways that it's built and called, but at the end of the day, it's trapping those vapors. And then we also have a vent valve that's going to draw in fresh air to mix with those vapors. And when the timing is just right, and that canister, I'm not going to say is full, but is ready to release those vapors and air, the purge valve is going to open and we're going to send all that vapor and air over to the intake manifold to be reburned into the engine. So we basically have a sealed system here. Rather than someone having to smell fuel or release it into the atmosphere, we're containing it at the beginning, we're recirculating it through the middle, and then we're burning it as the vehicle's running. That's going to help, again, with the EPA and CARB's mandates to make sure that it doesn't go into the atmosphere. So it's a pretty unique system. And again, different manufacturers are going to do it different ways. And here's how they do it in some of these applications. And one of the purposes of this slide is not only to explain the different types of leak detection systems that we're going to be dealing with here, but also to show that with our category and with what you have available to your customers, there really isn't a system in place that you cannot service your customer with. So when they have that diagnosis come in and they have that vehicle they have to fix with an EVAP system, you'll know we have everything available for them. So the types of leak detection systems that are primarily found, you've got the ESIM, which is what some manufacturers refer to as the Evaporative System Integrity Monitor, so the ESIM. And this particular one, there's actually not a vent solenoid per se that's turned on and off, but if you look deeper inside the ESIM, there's actually weights. And so depending on the pressure of the system or the vacuum of the system, it's going to move those weights and lift them off their seat or put them back down on their seat, depending on the conditions. And that's going to allow the fresh air to come in or the fresh air to go out. And so because these weights are naturally going to seal the system off, it can now burp itself by lifting or releasing those weights. But in normal driving conditions, it should be naturally sealed at all times until it's ready to do what it's supposed to do in that burping scenario. And there's also a set of contacts in there and a rubber diaphragm. Now, the ESIM is going to act as both the vent as well as the monitoring device. So it's going to vent the system, but those contacts are going to send the information by changing the voltage back and forth to the PCM. And that's how the PCM is going to know if there is a leak in the system and if the EVAP system is working properly. So in this particular example, we're not even worried about a fuel tank pressure sensor on this vehicle. The ESIM's doing a lot of the work and carrying the load when it comes to getting the PCM the information it needs to know that we don't have a leak. Now, if we go to older Chrysler systems, they would use the mechanical leak detection system or the leak detection pump. Now, this one had a vacuum applied to it, and it was electronically controlled. And you can think of this kind of like a bicycle pump, right? So it's going to be reading and calculating the size of the system. How much fuel is there? How much air is in the tank? And when I figure that out and I know I've got the system calculated, I know what I have, it's going to say, okay, well, based on this information, I should take 6 pumps to pressurize at a certain level and get this system taken care of. Well, if it knows that it's going to take 6 pumps and it ends up taking 10 or 12, or it just continues to pump without sealing, it now knows we have a problem. And so even though this is kind of a rudimentary design, it's kind of,
intelligent as well in the sense that it knows what it needs to do. And when it does that and it doesn't work, it knows we have an issue. So that's one system that can be found. Then if you fast forward, we also have electronic leak detection pumps. So this is a little bit of a different system. It's going to use an electronic motor instead. And really, this was only used for a couple of years before they kind of went all in with that eSIM. But this is just one more design and one more variable that's going to add to that confusion for the technician. There's, again, remember the EPA and CARB didn't say you have to use this, that, or those. It just said use something to make sure that we don't have leaks into the atmosphere. And so every manufacturer is doing something a little bit different. And that makes it a little bit harder for the technicians when it comes to diagnosing. They have to learn a lot of different systems. And that includes the last one here, the electronic vacuum pump. Now, some manufacturers like Toyota, they've been using these for nearly 20 years. So a lot of technicians, have a pretty good idea of what to do with them. But in these, there's a lot of electronics and componentry going on inside. There's different valves, there's calibration orifices inside, there's pressure sensors, there's an electric vacuum motor in there. So when it comes to the electric vacuum leak detection pump, there's a lot of opportunities for something to go wrong. So again, the point here on this slide is to say, regardless of which system, the goal is the same, making sure that there are no leaks present and being released into the atmosphere. And there's going to be different systems that do that. It's going to create a lot of different diagnoses for the technicians that have to go through. But at the end of the day, regardless of what vehicle comes through their bay and what diagnosis they have to do, when it's time to replace a part, they know they can count on you because we have a full line category that's going to serve the purpose of those customers and get them the parts that they need. So real quick, some of the most common reasons why these fail, obviously caused by age, mileage, general wear, and also poor OE designs. I think Jesse's going to allude to some of the things that we've done to fix those OE design flaws. But, at the end of the day, damaged and worn components are going to happen, especially with that high mileage, right? And when that happens, if a diaphragm is cut or a diaphragm is weak, you're going to have system leaks. You could also have solenoids and valves sticking open, and that's going to cause a leak as well. So really, time and age and general wear is one of the most common reasons, along with poor OE designs. But we can't forget about electrical issues as well. Again, heat, vibration, and general wear. This is on anything. We've talked about this with fuel injectors. We've talked about it with ignition coils and cam and crank sensors. Anything that has a pigtail plugged into it has to send that information back to the PCM so the PCM knows what's going on. Well, if we have corrosion or road brine or something like that built up on it, or we have a squirrel nesting in the engine chewing on a wire, we're not going to be able to get that information back to the PCM. We're going to have a check engine light. So in some cases, we may only need a pigtail to fix the EVAP system, or in other cases, we may need to fix a major component along with the pigtail. And again, going back to the full line category, we're going to be able to take care of those customers' needs, regardless of which version of that, answer it is. And then a couple of quick tips for you. And this is for your technicians. Anytime an EVAP repair is performed, we need to make sure a self-test is run afterwards to verify, one, no DTCs have returned, and two, we don't have a leak in the system, and obviously we can purge the vapors. And that self-test is going to do that for you, right? And even if a DTC hasn't returned, but we can't quite get the vacuum built up, or we still are detecting a leak, some cases we may have to use a smoke machine to find the leak. And even a very small leak in the EVAP system can cause a lot of smoke. So this is a really good way to identify leaks without having to tear the entire system apart and try to figure out what the next component is that might be broken. So always do a self-test. Make sure it can do its job. That way, whenever we send it back on the road with the customer, they're not going to be coming back with another check engine light. Another way to avoid that is to replace the fuel vapor canister when replacing a failed purge valve or solenoid. It's very common that when a purge valve and solenoid fails, it usually doesn't get the customer into the shop until many, many miles later. And at that point, we may have, a filled canister. We may have a damaged canister. We for sure have not been purging the vapors out of it. So that could have caused damage to the canister as well. So by just replacing the purge valve, we may only be fixing half the problem. Always a good idea just to go ahead and replace the system and do the job right the first time. And don't forget, diagnostics on turbocharger vehicles will require some more complex testing. And if you go back and watch our power hour from last month, if you go to YouTube and look up the power hour schedule, you'll see Ryan talks a lot about this when he talks about EVAP diagnosis on turbocharged engines. And so that's just a little, like I say, a brief, kind of rundown of how it works, what causes it to fail, and why it's such a topic of conversation right now with the category growing as much as it is, and the amount of vehicles being repaired because of it. So with that, I'm now going to pass it over to Jesse to tell us a little bit more about the program and how it can benefit you and your customers. Jesse, the show is yours, sir. Take it away.
All right. Well, thanks, Corey. Well, now that we've covered the technical aspects of EVAP, let's jump into BWD's industry-leading EVAP program. So when you reach for that BWD box, this is what you're getting. 15 global R&D centers, 21 manufacturing facilities, including Greenville, South Carolina, Independence, Kansas, which specialize in emission control. You get the full battery of tests performed on our parts, and BWD takes things a step further with on-vehicle testing. Finally, you get top-notch sales support provided by our expert trainers, digital content and marketing materials, including videos, flyers, and of course, the full product catalog. The product management team's always on the lookout for emission-related recalls and TSBs to suss out opportunities where BWD might offer a solution. A great example of this involves failing purge valves on a number of late-model GM vehicles, including the Enclave, Encore, and Traverse, just to name a few. BWD manufactures valves designed for improved durability to replace these failing OE units. So let's take a deeper dive into a couple of those. Now here's an example of an engineering improvement we've made on a popular GM canister purge solenoid. The OE unit has a plunger design susceptible to leaks caused by cracking or tearing. We were able to design and manufacture a new component that works exactly like the original, but with an improved design that doesn't cause the seal to fail. And here's another example of an engineering improvement we've made, this time with a Ford canister purge solenoid. The OE unit on many popular Ford vehicles fails at a higher than normal rate because the plunger breaks down and debris from the plunger can cause it to stick open. So we redesigned the plunger, replacing the flaps with a much more durable 360-degree ribbed plunger stop. Now, you've heard it before, but it bears repeating. Quality EVAP components are crucial for a vehicle to function and perform properly. So what does a comprehensive EVAP program look like? Well, you'll want a program that offers the parts needed for a complete service. Remember, these are systems, and your supplier should be able to offer everything needed for the entire EVAP system, not just part of it. You'll also want parts that are tested for durability and proper functionality, not just in the lab, but on actual vehicles as well. And finally, you'll want design improvements where necessary for improved durability and a longer service life. The part will function as intended by the OE, properly integrating into the vehicle's EVAP system. Our industry-leading coverage will allow you to better service your customers. So let's take a high-level look at what BWD offers as the aftermarket's most complete EVAP program. As you can see, we've got canister purge solenoids and valves, vent solenoids and valves, vapor canisters, leak detection pumps, and purge and vent hoses. Now, it might be helpful to keep in mind that the terms valve and solenoid are essentially interchangeable, whereas valve simply refers to a complete assembly that would include a solenoid. Now let's take a look at how BWD measures up to the competition. Well, folks, the numbers don't lie. BWD leads the aftermarket when it comes to full-line EVAP coverage. This is especially true of the most critical components, such as vapor canisters, purge and vent solenoids and valves, and EVAP hoses, which means advantage BWD. Let's take a look at some eSIMs here. Now, all BWD eSIMs are designed and built at our Greenville facility in South Carolina, and I can't say enough about the work our engineers have put in to make these the best eSIMs in the aftermarket. Now, our eSIMs are just another example of BWD's attention to detail that you'll find across all of our product lines. For example, the seal you see on the right of your screen, not only do we include it with all of our eSIMs, our design also matches the OE-style H-shaped profile, where most of the aftermarket competition is only supplying a traditional O-ring. And it's important details like this that elevate the BWD brand, and something you can be sure to mention to customers. Now, as Corey was talking about before, leak detection pumps, they're one of the more complex components in an EVAP system. And, as the name suggests, they allow the EVAP system to be pressurized to test for leaks. And given their complexity, you shouldn't be surprised to hear that they require expert manufacturing to perform correctly. Our incredible team at the Greenville facility that I just mentioned designs and manufactures some of our most popular pumps to match OE specifications and set the aftermarket standard for quality and durability. Now, in addition to offering the most complete EVAP program, we also have the smartest product offering. All 9 of the GM OE numbers you see here use the exact same canister purge pump. The only difference are the brackets. The CP10081 is a direct replacement for all of these OE numbers, allowing you to cover a ton of popular GM vehicles with just one BWD part number. And it's also important to note that this consolidation is fully supported by GM in accordance with their service bulletins. So here's what a complete EVAP repair looks like today with the 2019 Ram 1500 with the 5.7 Hemi standard fuel tank as our example. As you can see, BWD offers everything needed for a complete and successful EVAP repair. And we also offer options for multiple configurations of this vehicle, such as the Pentastar V6 extended fuel capacity models. And remember that eSIM O-ring seal I mentioned earlier? In addition to including it with our eSIMs, we also offer it as a standalone part, VCS 100. And of course, this is just one example of BWD offering all the parts needed for a complete EVAP repair. And here's an overview of BWD's emission control offerings, complete programs just like EVAP. And as you can see, we've got all the coverage needed across crankcase ventilation, EGR systems, and diesel emissions. Now, due to extreme temperatures, water, chemicals, dirt, and road salt contamination, the underhood environment is, of course, extremely hard on auto parts. And that's why our manufactured emission control products undergo rigorous examination and product validation, including extensive performance benchmarking, product lifecycle testing, and end-of-line testing. Finally, to validate our stringent processes, many BWD emissions products undergo live on-vehicle testing at our Texas facility. Well, thanks everyone for your time. I'm going to hand things over to Aaron in Marketing Services to take us home. Aaron?
Awesome. Yeah, thank you. Thank you very much, Jesse. Nice job, Corey. Yeah, I think these guys did a really good job of explaining the program as well as some of the features and benefits of the products. And I just want to quickly touch on some of the materials that we've made available to help you take some of this message to the street and to also help communication at the counter. So the first piece is very new. It's a simple 4-page brochure that describes our entire EVAP program. It kind of surveys the entire product offering and then speaks to some of the specific design improvements that we have in some of the parts. The next piece I'll talk about is that 2-sided flyer up there on the top right. That's a new item spotlight. The front of it showcases numbers that have been introduced in the last few months. This just shows our commitment to continually add new numbers for late model vehicles. But the part of it that's probably even a little more valuable to you is the backside, and that features our up and coming numbers. These are parts that have been introduced in the last few years that are starting to see very, very strong sales out. These are parts that we do recommend folks add to inventory because these are going to be the A movers in the future. Moving down, we also have a Just the Facts piece on the pump that Jesse talked about earlier. This is a real effective piece for us to explain this part and encourage distributors to add it just because it covers so many vehicles with one part number. That's been very well received. And then, we do have a piece that's not specifically EVAP related, but we do have a 6-page brochure that speaks to the entire emissions program. So it surveys the program, talks about what we have for crankcase, exhaust gas recirculation, as well as diesel specific emission components. This is something that's, very effective on the street when we're trying to explain the entire program to service providers or to diesel techs.
And then additionally, we also try to support you digitally as best we can. We do have a dedicated YouTube channel for BWD with about 500 technical and installation videos on there. We have some make model specific playlists available. And then the other thing that are created are digital product portfolios. So we have one dedicated to our entire emission control program. It features very detailed technical information, some training tips. So this is a really handy guide if you want that next level of information and content on emission control products. So lastly, just as a way to bring it home, what you get inside the BWD box is leading coverage. That's one of the big selling points of this program is it's designed so that you don't miss any sales. As well as very specific and pointed engineering upgrades on designs that have some weak points from the factory. So we do have design improvements that are specific for durability. They function the same way, but they will allow the part to last longer than the original that failed. And then we have the sales support. We have the additional flyers, brochures, videos that really make this a complete program and make it easier for you to talk to your service provider customers about. So with that, thank you to Jesse and Corey, and hope you have a great day.
And thank you as well, Aaron, and thank you as well, Jesse, and thank you everybody for being here. Our hope in this is one, it kind of opens your eyes to, how big and broad the EVAP, category can be and how it can look for you in the sales aspects. And hopefully in the next, 20, 30 minutes, you're going to get a call on an EVAP component and you're going to know exactly what to recommend because you have it. We're making sure it's durable, we're testing it properly, and we're making sure it's going to be adaptable to the vehicle it's supposed to be on and work the way it's supposed to, and keep that car out of the bay and keep that check engine light off. So with that, thank you again, everyone, and we'll see you next month when we talk about advanced ICE technologies. Have a great day, everyone.